In this video, I'm going to show you the creation of the Heapsort code requested on the last slide in the lesson notes. I'm going to use the priority queue class that was shown in the lesson notes. Not just because that's what was shown in the lesson, but also the priority queue has a wonderful copy constructor, which would take another priority queue that might be not organized in min heap fashion and turn it into a min heap. So if you think about it, when we remove the root node, that's the condition we have with the remaining heap. So therefore, we can turn it into a min heap to get the next root node, which would be the next lowest value as we're adding things to the array. So we will create our heap. Okay, we'll need an add method in order to add the items that we are adding to our heap. And the other advantage of the priority queue is this add method will add them in the appropriate order. So in other words, it will automatically bubble up a lower number to its appropriate location on the heap as it's being added. So we'll create add method receiving an integer. And then add that to the heap. Okay, now we will create the method that will create the array, and we'll call it what the industry frequently calls those items, which is toArray. Obviously, we're going to be creating an array. And how big is it? Well, it's designed to be the size of the heap. The priority queue class has a size function, so therefore we just get the size of the heap, and that is the size of the array we create. Now the lesson notes ask for this to be done recursively. So now let's think of what is our recursive method and what it's doing, so we know how much we have to do in the toArray function before we call the recursive routine. So what we have with the priority queue class is a poll function, which will obtain and remove from the heap the root node. The priority queue, as we've added things, will ensure the min heap characteristic. So lowest value is on the root node for us to poll. So basically what we're doing is each time we're getting a value for the array, is we poll the root node, we add that item to the next position in the array, and we rebuild the heap using the copy constructor. And we keep doing that so long as there are items on the heap. So that's our recursive method. So all we really need to do that is pass the array to which we want to add the items, pass the heap, and pass the current index into the array. The recursive function does everything else for building the array. So now that we've declared the array, all we have to do is call the function that's going to be getting the root node. So therefore, the array that we're going to be getting back will be the result of, I'll call it get root, and we'll pass the array, pass our existing heap, and pass the existing index, which right now is 0. We haven't added anything to it. And then that's the item that we return. Now let's build our recursive function. All right, so there's our parameters. First parameter being the integer array, the second parameter being the priority queue or the heap, and the third parameter being the index. So then what are we doing here? All right, as I said, the first thing we're doing is we're getting the root value from the priority queue. I believe the method is called getHead. I have priority queue set, and I'll just verify that. No, it's poll, of course. So polling that item. That gets us the item from the queue, and since it's a poll rather than a peak, we are getting the item and removing it from the queue. That is the guy that gets added at this index position of the array. And we increase the index. We avoid an array index out of bounds exception because we won't actually add if there are no more items on the heap. So that's fine. So now we've removed the item from the heap. That's what the poll method did. So we're only going to repeat the recursion if the current number of items on the heap is greater than 0. If it is, we will call to get our root passing A, passing Q, and passing I, because I has been increased. And when we are all done, we simply want to return the new array. That's the recursive routine that is building the array from that. Whoops, I forgot here, before calling root, I need to create the new queue. Big fingers, I sometimes make typo errors. We're sending in the current queue that is missing its root node because it was polled, and making a new min heap so it will find the smallest value and bubble that up to the root node, creates a new priority queue, and that new min heap is what gets passed recursively to the next call, the next recursive call of the get root method.